Hello, I'm Mark Long with Carlson Software, and today I'm going to show the Rational Rainfall Library within Carlson Hydrology. The Rational Rainfall Library uses IDF curves to provide average rainfall intensity data for particular storm events. With a known rainfall duration and frequency, an intensity is calculated via the IDF curve and applied to the rational method to obtain the peak flow for designing the sewer network. This data can be downloaded directly from the NOAA National Weather Service website. The website here shows the NOAA Atlas 14 maps for the NOAA, and we can come in here. Typically, I like to do precipitation intensity and a partial duration. As you slide down, you can see a map of the United States. We can take the cursor that's shown here in red and slide it over to our focus point, and we can then zoom in and then get even closer so that we can kind of pinpoint our site location. Okay. So you see Wake Forest, North Carolina. Here's the latitude and longitude and also the elevation. These numbers you could type right into the program and it'll go and download based off your latitude and longitude. If we scroll down, you can see the actual data that will be downloaded directly into Carlson software. The IDF equations would be developed from this table. In order to download the data for a specific location, you can either go to Settings, Drawing Setup, and down about midways is where we can set our projection, our zone, and the lat line datum. Once this is done, you can click OK. Next, we will go to Network, go to the Sewer Network Libraries, the Rational Rainfall Library. Select New, NOAA Atlas 14, and we can enter a name. So we will call this NOAA 14. And you can see that the latitude and longitude are set based off of North Carolina grid. So then we can hit OK here. The computer program then goes to the NOAA website and downloads the data that I previously showed you directly into the program. The next method we'll choose will be rainfall intensity. We go New, Rainfall intensity. We're able to select the return periods like so. Just check in the boxes on and off of what you may want. Typically a 2, 10, 25, 100-year storm. Click OK. You come down here to add a duration. You can select 5. Enter, and you type in the values. This method allows you to just enter in the rainfall intensities of various durations for any of the 1, 2, 5, 10, 25-year storms, return periods, and computing the IDF curves. So you type in this information, you give it a name. We'll call it INT for intensity. You're able to come in here and just say, type in these values manually, or if you have this data built into a CSV file, or you can obtain it, you can import a file. By importing a file, you will import the CSV, comma separated format. You select on the one you want to import, you click OK, and the values will be entered for the return period that you choose. Again, when you're done, you can hit the computation button and you're able to see the values for the rainfall intensity as well as the coefficients used for the IDF equation. Down at the bottom, we can select our storm event. let's just say the 2-year, and we'll go 7.5 minutes, and it should be somewhere between here and here. So with that being said, we can close and select OK, and we've added the rainfall intensity to our chart. Next, we will go down into the IDF equation coefficients. So let's do new. I enter the IDF equation coefficients, and you again select your return period here. We'll do the 2, 10, 25. We'll just say those three for the time being. And we will click OK. And now we just need to give it a name. And then we can enter in some of the values here. And I'll just use some that I've used in the past. So we'll just go down and input the A's. Then we'll go to the B column, and I'll just type these in as well. And then finally to the N column. Once this is done, you can hit the computation button, and you will see the rainfall intensities for the ones that you put into the IDF curves. And you can say OK, and it gets added to our list. Next, we will talk about a fixed rainfall intensity. So here we will select new, and our fixed rainfall intensity. This method creates a rainfall entry with a fixed rainfall intensity. When you choose to use this storm event, this fixed intensity will be used in your hydraulic calculations directly. For example, I use this for gutter spread. So let me show you how this one works. We click on fixed rainfall intensity. Again, we name it. Let's call it GS for gutter spread, and this is simply 4 inches per hour. Click OK. It shows up in our library. The next one that I would like to tell you guys is about the rainfall intensity lookup table. This method is very similar to the rainfall intensity method, but this one just interpolates values linearly. This method also allows you to just enter in the rainfall intensities of various storm durations as well. So you can just manually input these in. And then again, you select your return period. Click OK. And again, add your durations. So you can add the 5-minute. Enter. You type in the values, and we'll just say 3, 7, 8, 9. Something just like that, even though these are, different numbers. It's just easy. We can hit the computation button. We can type in select the 2-year storm, and let's just say for 5 minutes, 3. And you can see that value matches here. So this is a check for you. You can name this, let's just say Lookup table, LUT. Now, also in here, you can also reset the return period. So you could come in here and turn off some of these, or turn them on, the columns will appear and disappear. So you can do that as well. And I'm going to click OK. And now, the next method that we have in our list is the rainfall total 2/100 year, or what's called as the TP40 maps. The TP40 method is used to define IDF curves for portions of the United States. It requires rainfall accumulation of 6 hours and 24-hour storm durations for the 2 and 100-year storm, and the elevation of the location. The rainfall depth can be entered either manually or from the TP40 maps. The computation button computes the rainfall intensities and the IDF coefficients. So let's take a look at that. We'll go new. We will go with the TP40 maps. We can just call this TP40. And what we can do here is actually select the map option down here. You are more than welcome to type in these values if you like, but we can select the map. We can go and select our state, which is North Carolina. In this case, we'll go for the 25-year storm 24-hour, select close to the location of our site. You get a rainfall in inches. You can click OK, and those values are input for you. If you look at the computation option, you will then see the rainfall intensities and the coefficients of the IDF equation have been generated for you. Next, we would like to talk about Hydro 35 maps. Hydro 35 method is used to define IDF curves for the central and eastern portions of the United States. It requires rainfall accumulations of 5, 15, 60 minute storm durations for the 2 and 100-year storms. You can select the map button to open the rainfall map and pick a state on the map to zoom into the state map, and then pick the location to get the rainfall depth. So let's take a look at this. We'll go new. We'll go with the Hydro 35. We'll call this H-35. And we will go to our map again, and you can see this is for central and eastern United States. If I click in the state of North Carolina, I'm looking for a 100-year return period, 60-minute duration. Pick on the map. You can see our rainfall is calculated. We click OK. The values show up here. Then, if we go to the computation method, we're able to see the calculated coefficients and the rainfall intensities. Thank you very much for using Carlson software. I hope this movie helps you understand our library system a little better, and take care.